This is part 3 of our video on exponential function review. So this is question number 3 that says solve each of the following. So these are all exponential equations. Our first one says 5 to the power of x plus 1 equals 3 to the power of 125. So when we are solving exponential equations, there are two different ways to solve. One of them is to write them as powers of the same base, and the other one is to use a log. So I'm going to go through both with you on the first question, and then as we work through the other two, we'll decide which one we like better. So 5 to the power of x plus 1 equals 3 to the power of 25. Option number 1 is writing them as powers of the same base. Sorry, I wrote options instead of option. So option number 1 is to try to write everything as powers of the same base. The power sheet is really helpful for this. I am going to look at the base of 5 and see, can I express 3,125 as a power of 5? And the answer here is yes, I can. It is 5 to the power of 5. So this is 5 to the power of x plus 1 equals 5 to the power of 5. And then because these are equal and they have the same base, 5 to the x plus 1 equals 5 to the 5. That means the two exponents have to also be equal in order for this to be equal, which means x plus 1 simply equals 5. So we just compare our two powers together, and then we're going to solve that equation. So I'm going to subtract 1 from each side to get that x equals 4. Now, I don't have to check these because there's nothing you cannot put into an exponent. All right, option number 2 is to rearrange So if I take 5 to the x plus 1, I'm just going to rewrite it back down, equals 3,125. I could try to find a way to eliminate a base of 5. So the inverse of a power with a base of 5 is a log with a base of 5. So this would become x plus 1 equals log base 5 of 3,125. And then I would evaluate log base 5 of 3,125. I would use my power sheet to help me with that. So 3,125 is 5 to the power of, oops, that's crooked, 5. So I could say this is log base 5 of 5 to the 5, or I could just say it's 5, right? 5 to the 5 is 3,125. And then I would subtract 1 from both sides and get x equals 4. There is a third option where you can take the log of both sides, and if that's a method that you've learned and like, you're welcome to do that. But these are usually the two methods that I tend to use. Okay, we're going to try the next one. I have 3 to the power of 4x take away 7 equals 1 over 19,683. So when I'm trying to decide whether or not I want to write them as powers of the same base or whether I want to rearrange and use a log, I usually stop to look at the number and see whether or not it's a nice power of 3. And if it is a nice power of 3, I think that writing them as powers of the same base is a lot easier. And if it's not a nice power of 3, then I would probably just rearrange and use a log. So if I look at my powers of 3, I do see 19,683 is 3 to the power of 9. But I'm not looking for 19,683. I'm looking for 1 over 19,683, which means my exponent must have been a negative number. So this is going to be 3 to the power of 4x take away 7 equals 3 to the power of negative 9. So like I said, if this number works out to be a nice power of 3, I will write them as the same base. If it doesn't, that's usually when I use the log. But you could use the log on this question as well. All right, now that I have one power on the left, one power on the right, they have the same base, their exponents must be equal. So 4x take away 7 is going to equal negative 9. I'm going to add 7 to both sides. So you get 4x equals -2. And then I will divide by 4. Now, it didn't say in the question that we should round this, so I think I might just reduce it. I can divide the top and the bottom by 2, and I get that x equals -1/2. All right, there's one more question. This is part C. It says 9 to the power of x equals 1,000. So first thing I would do is look to see, is 1,000 a nice power of 9? And the answer to that question is no. 1,000 is somewhere between 729 and 6,561. So that means it's something between 9 to the 3 and 9 to the 4. So 9 to the 3 point something. It's going to be a decimal. So since it doesn't work out nicely, this is where I would use a log. So if I take this 9, the base of 9, to the other side, it becomes a log base 9 of 1,000. And then from here, if you have a calculator that can do log base 9, that's terrific. Mine does not, so I either have to convert it into log or ln. I like ln, so the change of base rule says we do ln or log of the argument, so that is 1,000, divided by ln or log of the original base, which is 9. So on my calculator, I have to do 1,000 and then ln divided by 9 and then ln. I could also use my log button. It would do the same thing. All right, that looks a little bit like pi, but not quite. So I have 3.143, which is roughly 3.14. And this one did say that it was okay to round. All right, and that's it for our exponential function review.